Hi everyone, this is Algebra 2, Lesson 1-1C, and let's jump right into things. We'll be starting with question number 23. You can label it which number you want. If you want to start out number 1, you can. But this one says, writing an equation of the form ax plus b equals c to solve a word problem. Meaning we want to take these variables and we want to exchange them for numbers, a numerical term. So let's read it. It says, Isabel sold t-shirts at a festival. She made $5 for each t-shirt she sold. Her expenses were $22. If she made a profit of $83, how many t-shirts did she sell? And what is it asking us to do? In part A, it says, write an equation that should be used to answer the question above. Let x represent the number of t-shirts. And then part B is solve the equation. So really all they want us to do is create an equation that's in the form ax plus b equals c, and then solve for the variable. So let's do that, but let's first go into the problem and kind of pick out the pieces that we need. So it says Isabel sold t-shirts at a festival. Great. But the next sentence kind of gets into what we need. She made $5 for each shirt. $5 for each shirt. When you see the word each, you should automatically be thinking of multiplication. Maybe I should rephrase that. You shouldn't always think of the word multiplication, but many of times each will imply multiplication for you. Her expenses were $22. Now, what are expenses? Expenses is where you're losing money. And forgive me, that is the word losing. It doesn't come out too well. I'll go ahead and rewrite that just to make it clean. You're losing money. Okay? So instead of a positive $22, really that should be a minus 22. And that gets me to my next point. Ax plus b can also be a minus b equals c. It can be a plus or minus b, depending on the specific example, such as the one here, that will be a minus sign. And then if she made a profit of $83, that's also important. Then how many t-shirts did she sell? Now again, part A is asking us to create an equation, meaning we'll need an equal sign. But it gave us what the equation will look like up here, the ax plus b equals c. Well, it says she made $5 for each shirt. It said let x represent number of t-shirts. So $5 for each multiplication t-shirt. 5x. Remember, that's 5 times x, same exact thing. 5 times x, 5x, same thing. Her expenses were $22. So she sold the t-shirts, and for each t-shirt sold, or in total I should say, her expenses were $22. Equals, she made a profit of $83. So that was part A. Part A just wanted us to create an equation, but part B wants us to solve. So let's go ahead and do that. Plus 22 plus 22. 5x equals 83 plus 22 is 105. Divide by 5 from both sides. X equals 21 what? What is it that we're looking for? Because we just can't have our answer be 21. Say you presented somebody and said, hey, well, my answer is 21. 21 what? What are we talking about? Well, it says 21 t-shirts. That's what we're trying to find. 21 t-shirts, and that's our answer. Try the example on the right, and then move on to the next one. 24 says, solving a decimal word problem using a linear equation of the form ax plus b equals c. We're basically doing the same thing we did in the previous example, but now we're dealing with decimals. So let's look at this. It says, Jose rented a truck for one day. That's kind of irrelevant. It kind of paints a picture that this person's renting a truck. There was a base fee of $16.99. Walked in, he's going to automatically pay $16.99 right off the bat. And there was an additional charge of 94 cents for each mile driven. Meaning, say we were to walk into a company and we wanted to rent a U-Haul truck, they're going to say, okay, right off the bat, it's going to be a base fee of $16.99. And then when you start driving that truck, we're going to charge you 94 cents for every mile that you drive our truck. Jose had to pay $235.07 when he returned the truck. For how many miles did he drive the truck? So let's create our equation. Let's look at this. As there was a base fee of $16.99 and then an additional charge of 94 cents per mile driven, or for each. Now the word each, you should think of multiplication. I also misspoke and used the word per, but we saw the word per in a previous example, I believe in 1-1b, where we said each could be per, or you could say per shirt from the prior example. Jose had to pay, now this is the total fee that he paid at the end when he returned the truck. So let's create an equation here. We'll make M equal number of miles driven. Because we don't know what that is, that's what we're trying to find. So it says that we had a base fee of $16.99 plus however many miles we drove, but we're getting charged 94 cents, 0.94 cents per mile, or each mile, which is times M, or 94M. Make that look more like a 4, equals, and we know that Jose paid $235.07. So now my equation is set up, but notice something here. I really in actuality have B plus AX equals C, and that is fine. If you wanted to rewrite this and put 0.94M plus 16.99 or 16.99 equals 235.07, that's fine. This equation is the same thing as saying AX plus B equals C. They just gave us the information out of order in the paragraph, and that's going to happen in real life where somebody's speaking to you in the business world, or if you're doing a side business or whatever, and they're throwing a bunch of information at you, some of which you don't even need, but you have to pick and choose out of that conversation what you need in order to make an executive decision or a specific decision or even a quote. There's many things, many situations. But let's go ahead and solve this. Let's minus 16.99 or 16.99 from both sides, because again, whatever I do to the left, I have to do to the right. We're left with 94 cents M equals $218.08 divide by 0.94 divide by 0.94. We are left with M being miles, 232 miles driven. You could leave it at miles because it's just asking us for miles. So Jose drove that truck for 232 miles. That is a lot of driving. Go ahead and try the next one on your own and move on to number 25. 25 says solving a word problem with two unknowns using a linear equation. So let's look at this word problem. A garden table and a bench cost $600 combined. So say we were to go to Lowe's or Home Depot, not only are we going to buy a table at Lowe's or Home Depot, but we're also going to find a bench. The cost of the garden table is 3 times the cost of the bench. What is the cost of the bench? So this might seem very confusing looking at it, but again, as always in word problems, it's best just to kind of break up the information we have. So let's use T, I'm going to put a capital T, for table cost. And then let's do B, which is the bench cost. Right now, we have no idea how much they are. We just know that the cost of the table T plus the cost of the bench B was how much? $600. It said a garden table and bench cost $600 combined, meaning you know we're adding. The cost of the garden table, the table, which represents T, right? That's what we said, is 3 times the cost of the bench. So T is 3 times the cost of the bench. So remember, 3B is 3 times B. 3 times the cost of the bench. That's what T represents. What is the cost of the bench? So what we need to do, and I'll do this in a different color, what we need to do is take T, what T represents, which is this 3B, and we need to plug it in to that T. So what do, in actuality, I get? I get 3B plus B equals 600. Now there is an invisible number in front of that variable B, and this is something we've covered in our past lessons. When you see a variable by itself in algebra, what number is in front of that variable? There is a number 1. You should have been thinking number 1. So now when we add our like terms, 3B plus 1B, I get 4B equals 600. Isolate the variable of B by dividing by 4. We get B equals $150. Make sure you put the dollar sign after. It could be 150 cents. It could be not even in dollars. It could be in won. It could be in different types of currency, but we know that we're regarding dollars because of the dollar sign up here. So again, sometimes your variable, for example, T, is not going to be a single term, specifically a whole number or integer like we've seen in prior examples. We're moving beyond that realm now at this point, and what we're doing is now we're basically creating expressions where our variable equals an unknown, which is 3 times B for this specific example. Try the one on the right-hand side and then move on to number 26. Writing an equation to represent a real-world problem, variable on both sides. That doesn't seem too scary. We've dealt with variable on both sides in prior lessons, but let's go ahead and read this and maybe even do a drawing to help us understand it. 2 pools are being filled with water. To start, the first pool had 992 liters of water, and the second pool was empty. So basically, we're looking at 2 pools. One already has water in it. The other one is completely empty. Water is being added to the first pool at a rate of 16 liters per minute. Water is being added to the second pool at a rate of 48 liters per minute. Let X be the number of minutes has been added. Minutes of water that has been added. For each pool, write an expression for the amount of water in the pool after X minutes. Okay, so we'll get into that in a little bit of a second after I'm done doing my drawings. Let's draw pool number 1 here. Pool number 1, let's do even a diving board, that sounds fun. Pool number 1 is being filled up. Say this is the deep end. And it's saying that it's already has 992 liters of water inside it. But then pool number 2 with a diving board is completely empty. There's nothing in there. There's 0 liters of water. So it's asking us in part A, for each pool, write an expression for the amount of water in the pool after X minutes. So X equals number of minutes. Now, what's the difference between an expression and an equation? Because this is really important for your quizzes and your exams. Basically, an equation has an equal sign, an expression does not. So we're creating an expression here. Amount of water in the first pool. So I know that there's an equal sign here, but for the sake of this, it's going to help you with part B. But how many liters of water did I start off with in pool number 1? I started off with 992 liters of water, plus it's saying water is being added to the first pool at a rate of 16 liters per minute. 16, and what do we use the variable for in number of minutes? X. And what this will do is this will allow us to figure out how many liters of water, if we were to make an equation out of this by knowing the total amount of water that this pool held, we can figure out how long it would take to fill up the rest of the pool. But what about the next one regarding the second pool? How much water did the second pool start off with? 0. Plus, what we're doing is now it says water is being added to the second pool at a rate of 48 liters per minute, plus 48x. We don't know how long right now, we don't know how long it's going to take or is taking to fill up the pool. We just know that it's doing 48 liters per minute. Now it's asking us for part B, write an equation to show that the two pools have the same amount of water. How do we do that? If they have the same amount of water, you want to set them equal to each other. 992 plus 16x equals 48x. I do not need to add the 0 in there because it's already implied. And what would happen is if we were to solve this, we would be able to find out what x is. But there's no need to do that because it's not asking us. It's just asking us to write an equation. It is not asking us to solve. Go ahead and try the one on the right on your own and move on to number 27. Number 27 says solving a word problem with 3 unknowns using a linear equation. So before we had one unknown, and then now we're moving on to multiple unknowns, which might seem kind of confusing. So let's try to just break this down and make this as simple as possible. Let's first read it just so we get a general idea of what we're dealing with. The sum of 3 numbers is 128. So right now I have no idea what those numbers are. There could be a lot of possibilities of what those numbers are to equal 128. The second number is 4 times the third. The first number is 8 more than the third. What are the numbers? All right, so this might seem really confusing off the bat, but again, let's break this up in chunks and try to make sense of it. The first sentence says the sum of 3 numbers. So I know sum means addition. I know there's going to be 3 numbers. I don't know what they are, so this is going to be variables. Is, you should be thinking equal sign, 128. So let's do this. We'll say the letter A is our first number. Let's use the variable of B, and we'll let that be our second number. And then we'll do our variable of C, which is going to be our third number. Again, we don't know what those numbers are yet. That's what we're trying to find out. So now that I have my variables, your variables could be any letters. I just picked A, B, and C. Yours can be literally anything. You start with I, J, K, whatever you want to do. But I know that the sum of those 3 numbers is 128. So I know that the sum of A plus B plus C is equal to 128. That I do know. Now this is where we move into talking about unknowns and trying to figure out what the other numbers are. The second number, what letter is my second number? B. So my second number, B, is 4 times, I'm saying B is 4 times the third. What's my third number? C. 4 times C. Again, 4C, the coefficient in front of that variable is 4 times C. So now I know what B is, or at least represents. I don't know the specific number yet, but I do have a possibility here. Now, the first number is 8 more than the third. So what is my first number? My first number is A. A is, right, is equal sign, 8 more than the third. So 8 plus C. In actuality, it'll make more sense if I do this. 8 plus C is fine, but it's saying that it's 8 more than the third. My third number is C, C plus 8, because 8 is more than C. Okay, what is it asking us to do? It's asking us to find the numbers. So let's do C first. Let's try and find C. What I'm going to do is I'm going to plug this 4C in for B. And then I'm going to plug this C plus 8 in for A. Well, let's see what that looks like. I have C plus 8, that represented my A, plus 4C, that represented my variable B, plus C, which was the tail end of that, right? My third number, equals 128. Now this should look very similar and something that we're able to do. What we need to do from here is combine our like terms. 1C plus 4C is 5C, plus another C is 6C, plus 8 equals 128. You minus 8 from both sides, you get 6C equals 120. Divide by 6, C equals 20. Now that I know what C is, I can plug that C either into this equation or this equation to start off. Either one, it depends which one you want to solve for. Let's solve for B first. B equals 4 times C. I know what C is now. C is the number 20. 4 times 20, B equals 80. Well, I know how to solve for A. A equals C plus 8, which is C is 20 plus 8, which is 28. A equals 28. And there we go. I know each of my numbers that combine to be 128, and a simple test would be to actually add 80 plus 28 plus 20 and see if it comes out to be 128, and it does. So that's solving a word problem with 3 unknowns using a linear equation. Try the one on the right-hand side. Moving on to number 28. Looked like this said 20, but it's 28. Solving a one-step word problem using formula D equals RT. Now you got to reach back in your memory, because you would have seen this beginning roughly 6th grade, if not before, but 100% in 6th grade. You should have seen distance equals rate times time. This is distance equals rate times time. When we're dealing with rate, what a rate is, it's generally talking about speed. Miles per hour, kilometers per hour, things of that nature. So let's read this. It says, a tortoise is walking in the desert. It walks at a speed of 3 meters per minute for 37.5 meters. For how many minutes does it walk? Well, let's look. A tortoise is walking in the desert. It walks at a speed of 3 meters per, okay, you should automatically be thinking of multiplication, minute for 35 meters. So what is our distance that this tortoise is walking in total? 37.5 meters equals, what is our rate? Well, it's saying that the tortoise is walking 3 meters per minute, right? What is time? Minutes. 3t. 3 times t, right? T is number of minutes. And then we solve from there. We just need to divide by 3, divide by 3. You get 12.5 minutes equals t. Meaning it took 12.5 minutes for that tortoise to walk 37.5 meters. Try the one on the right-hand side, and then move on. Solving a distance, rate, time problem using a linear equation. So this is actually a very famous style algebraic question that a lot of people like to ask. So let's read it. 2 trains leave the station at the same time, one heading west and the other heading east, so they're going in opposite directions. The westbound train travels at 75 miles per hour. The eastbound train travels at 85 miles per hour. How long will it take for the 2 trains to be 192 miles apart? Do not do any rounding. Okay. So let's draw this. We have a train. Now mine's not going to look like a real train. I'm sorry. We'll do like a smokestack. Some wheels. One train is heading east, and the other train, I'll put up here, is heading west. The westbound train is traveling at 75 miles an hour. I'm just going to put this in red. 75 mph. The eastbound train is traveling at 85 miles per hour. And it's asking us how long does it take the 2 trains to be 192 miles apart. So we need to set our variable. I'm going to choose x. You can choose any variable you want, but x is going to be hours, or number of hours. And it's saying we're trying to figure out 192 miles apart. And we need distance traveled by train number 1 plus the distance traveled from train 2. We just don't know how long they were traveling in either direction. For example, the train that's going westbound could have been traveling for so long, and then the train traveling east could have been traveling so long. But we need to just see how far they're going at the same time to reach a specific distance. So 192 equals how fast was the train that was going west? 75x plus the train that was going east, 85. And then simple solve. 75 plus 85 is 160x. Divide by 160, you get 1.2 equals x. More specifically, x equals 1.2 hours. Perfect. Go ahead and solve the one on the right, and then move on to number 30. 30 says, finding side lengths of rectangles given one dimension and an area or a perimeter. All right, so let's read this. It says the perimeter of a rectangular parking lot is 288 meters. If the width of the parking lot is 58 meters, what is its length? Well, let's draw this out real quick. Let's draw a rectangular parking lot. So here's my parking lot. It's not a perfect rectangle, but it works. We know that this is going to be length, and this is going to be our width. And it's the same thing for the other sides. This is our width, and that's our length. To find the perimeter of a rectangle, this is something you need to just memorize. It's a formula. P for perimeter equals 2 width plus 2 length. But it gave us some information inside the problem. It says that the perimeter of the parking lot is 288 488 meters. If the width of the parking lot is 58, meaning a W equals 58 meters, what is the length? Well, let's plug it in. 2, and then what does my W equal? 58 plus 2L. Again, you just have to memorize the equation. This wasn't something that was given. It's just something that you just need to pull back from your memory. So I get 288 equals, what's 2 times 58? You should get, I believe, 116 plus 2L minus 116 from both sides. You get 172 equals 2L. Divide by 2, you get 86 meters equals our length. And there's a way of testing this. How do I know that my answer is actually correct? Well, this is going to be our length here, 86. This length is going to be 86. And the problem said that our width was 58. If you added up 58 plus 86 plus 86, you should get 288. So that's just one way of checking your answer. Go ahead and try the one on the right and then move on. Oh, forgive me, we actually have to try the area. So before we do that, let's look at this. It says the area of a rectangular pool is, so I'm right here, 5,487 meters squared, okay? Because we're dealing with area, that's why we have the meters squared. If the length of the pool is 93 meters, what is the width? Well, we need to know the area of a rectangle. The area of a rectangle, again, this is just something you have to memorize, is area equals length times width. Length times width, or LW, same thing. It tells us what the area is. It tells us that the area is 5,487 meters squared. Furthermore, it tells us the length. It says the length of the pool is 93 meters. Times, well, we don't know what the width is, times W. From there, you just divide 93 from both sides. You get 59 meters equals your width. And there you go. Simple as that. And now, if you did 59 times 93, you should get 5,487, just to try and make sure that your answer was correct. Now you can try the problems on the right-hand side and see if you could find your answer in the play pause it. Let's try number 31 here. Finding the dimensions of a rectangle given its perimeter and a relationship between sides. All right, so let's read this. The length of a rectangle is twice its width. If the perimeter of the rectangle is 36, find its length and width. Well, let's kind of decipher this a bit here. It says the length of a rectangle is twice its width. The length L of a rectangle is right, equals twice, which is 2, its width. Put W. Well, I have an equation here now. My length is 2W. If the perimeter of a rectangle, now we should reach back. What is the equation for perimeter of a rectangle? We just did it before. You have 2 length plus 2W, or 2W plus 2L, same thing. It says the perimeter, 36, equals, find its length and width. Well, I know what L is. So let me just write out perimeter like this so we don't get confused. And I'm going to plug this in for that right there. Why am I doing that? Because I know what this variable represents. It represents 2W. 36 equals 2 times 2W plus 2W. 36 equals 4W plus 2W. 36 equals, what's 4W plus 2W, meaning we're combining like terms. 6W, you divide by 6 from both sides, you get 6 equals W. But that's the width, right? It also says find the length. So we have a portion of what we needed. All right, we have 6. But we need to find the length. Well, I know I'll put this in blue. I know the formula for the length because it gave it to me. Length equals 2 width. So let's plug that in there. Let's have L equals 2 times 6. My length equals 12. I am not done yet. I don't want to just leave it as 6 and 12. What this really is, and my complete answer, is 6 centimeters by 12 centimeters. That's really the answer. So please don't leave it as just 6 and 12. Please put in the measurement that's being given, which is 6 centimeters. It could be inches, it could be feet. It just depends on the problem. It could even be yards or miles, things like that. Try the one on the right-hand side. Solving for a variable in terms of other variables using addition or subtraction, basic, solve for n. So looking at this, I have 16 plus n equals m. So all I want to do is just isolate and solve for this variable. So don't be confused. Just because you have a variable over here does not really mean that much. And let's see an example right now. How can I get n by itself? I somehow need to move this 16 over here, and we minus 16 from both sides to do that. Notice these 16 cancel to 0. I bring down my n, and now I have n m minus 16. There we go. That's it. That's all we need to do. Go ahead and try the one on the right by yourself, and then move on to number 33. Solving for a variable in terms of other variables using multiplication or division. So we want to solve for h here. This is what it's asking us to do. Solve for h. So I have a equals 6h. How can I get h by itself? I need to divide by 6, right? Because these will go and create a 1. But if I did that to the right-hand side, as you see, I have to do it to the left-hand side. So we get a over 6 equals h. And there we go. That one is done. Try the one on the right-hand side. Solving for a variable inside parentheses in terms of other variables. All right. So this might look a little tricky. But what we want to do is solve for b. The first question is we want to figure out, how do I get rid of that 9? I need to get rid of that 9. It's on the side that b is, and again, I want to get b by itself. To get rid of that 9, we divide by 9. Divide by 9. We divide by 9 because these will cancel out to be 1. So I get r over 9. I don't want you to confuse this. My 9s look a lot like my a's, so let me be a little bit more clear here. Equals b plus a. Well, I have another dilemma. My b is still not isolated by itself. How do I get rid of that a? If there's a positive a, to get rid of it, I need to minus a. And if I minus a from the right-hand side, then I need to minus a to my left-hand side. So now I get, maybe this will help you visualize it a little bit better. I'll leave a gap here. R over 9, and I'll minus a here. That way, when I bring everything down, r over 9 minus a equals b. It will be a lot cleaner, and that is our answer. So sometimes you'll see me write the a at the far end of it. I just want you to visually see a different representation of it, but writing it in the middle there is just as fine as well, as long as you're not getting confused. Try the one on the right-hand side. And let's move on to our last problem here of 1-1. Solving for a variable in terms of other variables in a linear equation with fractions. So we've seen fractions, specifically how to clear fractions. And I'm using that word clear because that was one of the titles of the sections that we did previously for 1-1. But how do I get rid of that 1/6 I need to do something with that 1/6. I need to take the reciprocal of 1/6, which should be 6 over 1. The reason for that is I want to get rid of it, but don't forget whatever I did to the right-hand side of the equation, I have to do to the other. So the 6 go on the right. I get 6w, or 6 times w, equals x plus y, that's a minus z. But again, it's asking us to solve for x. So you can either start with the y or the z. I'm just going to minus y from both sides. Now I get 6w minus, maybe look better if I do that, equals x minus z. Let's isolate x by adding z to both sides. I get 6w minus y plus z equals x. And there we go. I have solved for x. And we are done with that problem. Try the right-hand side on your own. And this will conclude Algebra 2, Lesson 1-1.